All right, we're going to go over the study guide, math one. We're going to finish the study guide, and then if we have time, remind me at the end, Miranda, to go over the problem that you said you had questions about. All right, so number 8, we are writing this in our notebook. I see a couple people don't have their notebook open. Please make sure that you open your notebook because we're going to continue in the notebook, please. We'll pause for the calls. Yeah. All right. Number 8 says a certain type of bacteria doubles. So we already know this is an exponential function because we're multiplying by 2 in this particular pattern. Once every 30 minutes. So it's going up every 30-minute seconds. So if x is 1, that's 30 minutes. If x is 2, that's 60 minutes. If x is 3, how many minutes is if x is 3? 120. Do you see that? Every 30-minute increments, okay? During each 30-minute period, approximately 10% of the total dies. Okay, so we got to find 10%, and 10% of that is dying. All right, so let's see which graph shows the best potential number of bacteria. So let's start with the X being, yes. You did finish number 7. Yeah, we did. You just finished going over. Yeah, number 7, we finished. Oh, okay. We finished number 7. The answer to number 7 was let me pull that sheet out so you can see it, okay? Yes. You got it? No, I don't have it. Okay, hold on. All right, so the starting amount of cows is 30, and it is doubling every 5 years. So it's going up by 5-year increments. So we got 2 here. Do you see that? So the next, so it'll be 30, then 60, then 120, so on and so forth. That's okay. And then we chose the best answer. Where's the graph? And we chose the one to be B. Okay. Yep. We circle B as our answer. Do you see it? Yep. Okay. All right. Okay. All right. So let's do this one. So 0. The starting amount was what? Did it say? Did it say the starting amount, or did they give us just a table? They gave us just a table. So starting amount is in the table in all of these is 10. Okay. They didn't tell you in the problem, but in the graphs, all the starting amounts are 10. So it's starting at 10. Okay. And so how many is it going? It's doubling every 30-minute period. Okay. So it's doubling every 30 minutes. So time in hours here. So by the time it gets to a minute, let's see what that is. So every 30 minutes. So let's do the first one. Double is going to make this what? When you double it, what does that make it? That makes it double 20. Okay, let's not put 20 down. Let's type in the calculator because 10% of that is gone. So 90% of it is staying. Okay, so let's type in 20 times the 90% because that's the amount that's staying. Okay, so 0.90, and that gives us 18. So we got 18. All right, so now let's double 18. What's 18 times 2? What's 18 times 2? Okay, and so let's find 90% of that again is going to stay. Okay, 10% dies, so 90% stays. So times 0.90, and what does that give you? 32.4. Okay. All right, and let's double 32.4. So multiply that times 2. Okay, and 90% of that is staying, so let's multiply that times 0.9. And then what does that give you? 58 and some change. So let's see if we can see that pattern in any of these graphs. Okay, so 30-minute increments. Okay, so the first 30 minutes would be about 18, right? So we got the first 30 minutes 18. All right, so this one is 20. Looks like it's at 20. Okay, and so if it's estimating, if it's the best answer, then yes, this first one would be. But let's see if we can find an even better answer than this, okay? All right, let's look at this one. This is going up by 30-minute increments. That's not quite right. This is not good, okay? Because hour Yeah, no, B is not the answer here. Because every 30-minute increments, it should be going 18 and then so on and so forth. So B is not it. Okay. Same kind of shape, but B, the numbers aren't right for B. Let's look at C. All right. This looks like 30-minute increments here. Looks like it could be 18. So that's pretty decent. Then the next number is 32.4. That looks a little decent, right? And then the next number, the next 30-minute increment is 58.32. And that looks good. This is so far the best answer. C is so far the best answer. Okay, and then let's look at this last one. All right, so in an hour, which is the second 30-minute, is 32. No, this is not 32. Okay, so this is not a good answer. So our best answer here is going to be C. The best answer here is going to be C. We looked at our numbers and it fits the pattern of our numbers. Any questions about this before we move on? Okay, close your laptop. You need to be writing this in your notebook, okay? Write in notebook, write in notebook. Okay? All right. Anyone still writing? Anybody still writing the table? Okay, let me pause for the calls. Please let me know when you're finished. Okay, so let's do this one, this particular problem. Okay, I'm going to simplify what's in the parentheses first, and then I'm going to multiply power of a power, multiply negative 1 times all the exponents. But I'm going to simplify this first, okay? So I'm going to simplify the numbers. 3 divided by 6 gives me 1 over what? 2. 1 over 2, okay? Then I'm going to simplify the x's. We got division, so we're going to say 3 minus a negative 2. What's 3 minus a negative 2? Not negative 5, no. 5. It's 5. So let me erase this and put 5. I'm doing this for space, okay? And then we're going to do the y's. Then we're going to do the y's. We got negative 4 as an exponent and then 6 on the bottom. So this is going to be negative 4 minus a 6. What's negative 4 minus 6? Negative what? 10. Negative 10. So I'm going to erase this and I'm going to put negative 10. Okay. Any questions about how I simplified the middle? Okay, so now I'm going to take this exponent here and multiply it times all the exponents in the parentheses. If you don't see, bless you, baby. If you don't see an exponent on a number or a variable, the automatic exponent is 1. So I'm going to go ahead and put 1s as these exponents here so I don't get confused. So now let's multiply negative 1 times all of the exponents in the parentheses. So first is 1, this 1 times negative 1, that's going to be 1 to now the negative 1. Then this negative 1 times this positive 1 is going to make this negative 1. Then this negative 1 times a positive 5 is going to make it a negative 5. Then this 1 times this negative 1 times this negative 10 is going to make it a positive 10. Any questions? Now, in order to make a negative exponent a positive exponent, if it's on the top, bring it to the bottom. Sit up, baby. If it's on the bottom, bring it to the top. Okay? So let's do it. All right, let's go ahead. Did I work with you on this yesterday? Did you already finish everything?
Yeah.
Did you finish the ones that we didn't do?
Yeah.
Oh, did you get those right? You don't know, do you? Okay, all right.
We only had 3 left.
Oh, okay, gotcha. All right, so let's do this. So I'm gonna keep going this way. All right, so I'm gonna move this to the top and this to the bottom to make them positive. So we got positive 2 to the first power on the top and positive 1 on the bottom. Move this down to the bottom to make it a positive exponent. That's positive now 5. And keep this on the top because it's already positive. So this is 10. Okay. So now what I have, 2 divided by 1, that's going to give me 2. We got y to the 10th. On the bottom, we got 1, which we don't have to put in front of. It's automatically a 1 in front of that x. So we have x to the 5th. Which answer choice is that? D. Okay, and pause for the calls. All right, the next one, zoom back out again. It says the tournament begins with 64 players. So 64 is the starting amount. Half of the players are eliminated. So half are eliminated. This is exponential decay. Bless you, baby. Half are eliminated. Okay. So 50% of them we know are eliminated, right? Okay. Each round, after each round. Place the number to complete the function. All right. So what are we gonna place before the parentheses?
64.
We're gonna put 64 here. What are we gonna place in the parentheses? 1. This is exponential decay, so we got minus here. And what are we gonna place here? 1/2 or 0.50. Since they got a half, then we're gonna put a half here. Any questions? Is there anyone that's lost? Okay. This is the calculator inactive part. You had to do all of this without the calculator. Pause for the calls. All right, this is calculator active. Okay, so let's look at this one. A certain population of bacteria doubles. So we already know this is exponential growth. Okay, we're multiplying by 2 to get to the next number every 30-minute increment. 60 minutes, sorry. 60 minutes. So that means if for the first increment is 60 minutes, then the second increment, what's six is how many minutes? Every time it's going up to 60. Come on. 120. Then third, add another 60 to 120, so on and so forth. Okay. The beginning with 50. So my starting amount is 50. This is my y-intercept. This is my starting. Okay. They already give you the equation right here, represented by that equation, where A is the total number of bacteria or the number of bacteria after T hours. So T represents the hours because it's every 60 minutes. Okay. Which of these is the appropriate domain? What is domain? Those are your x values. Okay. Remember, your x values also represent, and it told you t, also represent the number of hours. Okay. So you have to think which one of these is going to make the most sense. So we're looking at all real numbers greater than or equal to 0, okay, because you're starting at the 60-minute mark or the starting amount. This makes sense because you can have part of an hour, okay? So far, this is a really good answer, okay? Integers implies that it can't be a halfway mark. So no, this is not a good answer here, okay? Equal to, greater than, or equal to 50. No, because what about the numbers that are smaller than 50? That's not a good answer. Integers in general, this is not a good answer because you can have part of an hour. Okay, it doesn't have to be right at the hour. You can have a half of an hour. Okay, no. And all real numbers greater than 50, which means you're starting at the 50th hour. No, because you have hours less than 50. So the best answer here would be A. Any questions about why A is the best answer? Any questions? Mason, what's wrong? Do you understand why A is the answer? God, listen. Remember how you say it? Okay. All right. Okay, baby. All right, let's look at this one. Which statement justifies why this point is a solution? Listen, this is an equation, which means this equation is going to graph a solid line because it's equal to. If it was less than, the answer would be below the line. If it's greater than, equal, let me do equal. Equal to sign, the answers are on the line. Answers on the line. Okay? In order for it to be an answer, it has to be on that solid line. If we have less than, this is less than, answers are below the line. Okay? If it's greater than, answers are above the line. You see, we're looking at this right here, a part of the equation. Above the line. That's where your answers are. If it is less than or equal to, it can be on the line or under the line. Answers on the line because there's an equal to sign, or below. And then the last one, greater than or equal to. Answers can be above the line or on the line. Okay, and I'm gonna pause for the calls. All right, here we go. Which one of these would be the best answer then? This is equal to, so it has to be on the line. So which one, when you read it, is going to be the correct answer? A. The ordered pair is on the graph. Okay, it's on that line. All right, let's move to the next one. Number 13, treatment of the feline, whatever that is. How you say this, y'all? Hyperthyroidism. That's what I think it is. Involves a single dose of radioactive iodine. It says the amount of radioactive iodine remaining following the treatment shows in the table. Okay, so look, we got 0 days, this is the amount, 8 days, this is the amount, 16 days, this is the amount. Okay, how much days in 20? This is an exponential function, so we're going to type this in the calculator. We're going to do exponential reg, okay, to get a exponential function. Okay, so we go, I'm going to clear my calculator, second plus 7, 1, 2. And we're going to go to stat first. Stat is here in the calculator. And we're going to press enter on edit. We're going to type in these ordered pairs. The X value is going to go in L1, Y values in L2. Please make sure you type it in so you'll know how to do this for your test. Come on, type it in, baby. Type in. Raise your hand if you're still typing before I move to exponential reg. Okay, go ahead. I'll pause. We're going to go to stat. Stat is here. We're going to go over to calc. And where do we go from here? 0, which is exponential, not lean. It's an exponential function, so we're doing expo reg. Press enter and see, look, we've got to find some table values. So we don't need to just press enter from this screen to get an equation. We need to make sure we do this, the vars. Second 1, comma, second 2, comma, then what? Vars. What's after that? Y vars. How many times we press enter? 3 times. Okay, this will put the equation in y equals, okay, without you having to type it there. And then that way you can go and view the function table. Okay, so remember this part. They're asking you now, we got our equations. They're asking you for how much radioactivity still remains after 20 days. So now we can look at our function table. What buttons do we press to go to the function table? What button do we press for the second table? And then we're going to go down to where for 20 days. So I'm going to search, go down for 20 days. And what is it after 20 days? 0.35033. Very good. Okay. And so which answer choice is going to be the best answer choice here? C. C. Okay, C is the best answer choice. Please don't forget how to type in an exponential function. You are going to go, if you want to write it down, you can, but to do exponential reg, you do stat, you type in numbers, and we have this in our notes. Type in the numbers, L1, L2, then you go to stat again, okay? You're going to go over to calc. I put the arrow over, and then you're going to go to expo reg. This is where you press L1, comma L2, comma vars, Y vars, and then we're going to enter 3 times. This is also in your notes if you want to write it again, because maybe you don't know where it is in your notes, you can write that again. I'm going to pause for the calls, okay? Oh, to go to your table, to go to table, some of you might want to write that down too. This is also in your notes. You press second and graph. If you have forgotten, you might want to write those things down. All right, let's do the next one. Look at this one. It says, which linear equation would intersect the exponential function? Okay, look, this is a line. They want you to find the point. They want you to write that line, okay, the equation for that line. So to write the equation for that line, find the slope. All of these slopes are different. The slope here is 1/3, 1/3. The slope here is 12. It's the number that's attached to x because all of it's in y equals mx plus b, which don't forget that that's the slope intercept form. The slope for this line is 3, and the slope for this line is 1. So if you find the slope, it has to be one of these numbers. That's going to be the answer. So if you remember the formula for slope, if you don't remember, that's why we're writing it. It's y2 minus y1 over x2 minus x1. To calculate the slope, you label the ordered pairs. The ordered pair here, x1, y1, that's the first point. X2, Y2, that's the second point. And this is the same formula. This is slope formula or average rate of change formula. Because sometimes they ask for average rate of change. You use the same formula. Okay? So let's substitute. What numbers do we put on the top? What minus what? 3 minus 27. What numbers do we put on the bottom? 1 minus 3. This is calculator active, so you can type this in. What is 3 minus 27? Negative 24. What is 1 minus 3? Negative 2. So now let's divide. What is negative 24 divided by a negative 2? Positive 12. Which one of those has a positive 12 slope? B did. Do you see that? How B had a positive 12 as slope. So this would be your answer. And we didn't even have to find B, okay? Because we already found the slope. All the slopes are different, so that has to be the answer. I'm going to pause for the calls. Anybody need me to go back up so you can see the other part of it? Okay. Yes, baby. All right. Next one. A computer company is currently earning 400 in profit a week, okay? And predicts the profit will increase by 5% each week. Oh, okay. So that's the one time they earn that. Okay, gotcha. All right, so it's going up by 5% every single week. The second company, this is company one, company two, right? Okay, so the second company, I'm gonna put first company here, 400, and then we got R is 5%, so that's 0.05. Okay, so let's move to the second. The second company is earning 900. and predicts to make an increased profit. So this is another increase, 2%, 0.02. Okay. How long will it take for the companies to make the same amount of money? So we need to write this as an equation. All right. So what kind of function is the first company? Growth. What's the formula for exponential growth?
Y equals C parentheses 1 plus R.
To the x power. This is also growth. So we're going to write the same thing here. Or to the t power. Same thing. Okay. All right. So how do I write the equation for the first company? Y is equal to, what do I put in the place of C?
400.
So we got 400 parentheses 1 plus what? To the x power. That's the first equation. How would I then write the second equation? 900. Very good. So these are the two equations. So they want to know how long will it take for them to be the same amount. So we're going to type them both in our calculator and see when the y values are the same. Okay. So to type in an equation, I'm going to clear my calculator because remember I got that other stuff in there. Second plus 712 instead of having just delete everything. I'm just going to clear it. So now I'm going to go to y equals, and I'm going to type in both equations. This first equation is 400 parentheses 1 plus 0.05 caret key x. Come on, Mason. You got to do what we're doing, baby, because that's part of the reason why you get so lost, okay? Because you don't do it when I'm doing it. Okay, let's type in the second equation. The second equation is 900 parentheses 1 plus 0.02 caret key x, okay? So now we are going to view the function table. What two buttons do we press to view the function table? Second and graph. So now we want to look to see when they are the same. Okay, so let's keep going down the x values. And then look, we could have just typed these numbers in to see which one instead of just having to keep going fumbling through the table. So in order to do that, if I want to check, if I want to keep going down and checking, that's fine. If not, I can press second window and I can press the X on the independent. That's the X. I want it to X for my X value so I can type them in, then go back to second graph. So X weeks, type in 4. It is not the same here. Then I can type in 6. It is not the same here. Type in 18. It is not the same there. And I type in 28 and we hope that it's the same. And it is about the same there. So it's going to be 28 weeks. Any questions about how I got the equation? I typed them both in. I went and looked at the function table to see at which one of these weeks is it about the same. Any questions? All right, let's do the next one. Okay. All right, so look, this is when a lot of people got confused. A sub 1 is the first number that's in the list, okay? So if I'm creating a list, this is the term, okay? And this is the output. Okay, so my first number in the list is 10. They didn't give a zero number. They didn't give the starting number. They gave the first number, which is the reason why they write n minus 1 because you didn't start with the starting number. They gave you the first number, not the starting number. So now this right here is just saying that you, in order to get the next number, in order to get a minus 1 or a sub minus 1, a sub n minus 1, sorry, in order to get the next number in the list, look, you have to multiply by 3. Okay? So in order to get the second number, what's the second number going to be? Multiply by 3, please. 30. Okay? What's the third number going to be? 90. What's the fourth number going to be? 270. Okay. Look, they're asking for the fourth term. So that's why we went to the fourth number in the list, and it is 270. That answer choice is what? D. Any questions? Pause for the calls. Please write. All right, let's do if we the study guide is priority. Yeah, it's a review. Okay, it's just a review. Yeah, this is more way more important. Okay. All right. In 1962, the average cost of a gallon of gas in the United States is 31 cents. Okay, 31 cents. Ooh, I wish. The cost of gasoline has increased 3% every single year. What is the average gallon of gas in this year? So look, this is increasing by a percent. So this is exponential growth. What's the formula for exponential growth? Any questions? Don't forget to the X power. Any questions about how I know it's exponential growth? How do I know? Yes, I'm sorry. Because it says it's increasing by a percent. No, it's because of inflation. All right, so here we go. So what's going to be your C here? 31 cents. This is where it started, okay? 1 plus 0.03. Good job, baby. To the X power. So this is the equation. So now we got to figure out how much gas it was in 1972. So how do we figure out what the value of X? This is my year. So what do we do to figure out what X is equal to? Very good. Subtract. The starting year was 1962. So we got 1972. Whew, that was before me. 1962. Okay, subtract those and what do you get? You get 10. Okay, so X is 10 years. All right, so type this in your calculator and let's see what we get. We're going to substitute. Miss Reyes, you could have just put 10 right here, right? All right, let's type this in and see what we get. Don't forget, you got 0.31 times 1 point what? 03 caret key what? 10. All right, which is not bad, right? Okay. So it only went up. All right. So how much money is gas going to be then? 0.42. So it's going to be about 42 cents. About. That's the best answer. About 42 cents. You see how these answers are so close? So you really got to know what you're doing, okay? They purposely put them that close. Anyone still copying? Okay. All right, let's look at this one. The first number in the list, I'm going to make a table again. Remember, X is the domain, which is the term, what term it is. And then Y is going to be my output. It's always my answer or my output. My first number, it doesn't give me my zero number, it gives you the first, A sub 1. My first number is 4. What am I doing to get the next number every time? I'm multiplying by what number? 1/2. I'm multiplying by 1/2. So my next number, I can type this in the calculator. I'm going to type 4 divided by 2. What's that give me? 2. I'm multiplying by 1/2. What's my third number? 1. What's my fourth number? 0.5. Cut it in half. What's my fifth number? 0.25. What's my sixth number? 0.125. Very good. What's my seventh number? Cut that in half. 0.625. Okay. My answer is written as a fraction. Do you see? Oh, sorry. My apologies, y'all. I forgot the zero. Okay. All right. Yep. Okay. So now, how do I make this in my calculator? How do I convert this to a fraction? What can I do? Type it in. Let's type it in first. And then what do we do? Math and then fraction. And then what do I press? Enter. And so what is this as a fraction? 1/16. Mason, did you see that? Because you're going to have to be able to do that, baby. Enter twice. What answer choice is that? Yes, baby, I can do it again. Do you understand how I got down to this, right? Okay. So you're gonna type in the decimal point zero. What is it? Thank you. And we're going to press math again, babe. And we're gonna press the fraction because we want to convert to a fraction, and then press enter.
Okay, thank you.
You're welcome. Anybody still writing?
What will be the answer?
All right, here we go. It says the frequencies for certain notes are shown below. Okay. So it's saying that if the frequencies is a geometric, so that means you're multiplying to get to the next number, multiplying to get to the next number, multiplying to get to the next number. What's the common ratio? What's the number that's being multiplied? So I'm going to work backwards and divide. So I'm going to work backwards and divide. Work backwards to figure out what was being multiplied. So I'm going to say this number here, 466.16 divided by 440, okay? And see what was being multiplied. And this number right here, 1.059. So what's the closest answer there? Yep. Okay. So work backwards and divide to figure out what was the number that was being multiplied. Geometric sequence means they're multiplying to get to the next number. So work backwards and divide. You can write that down if you need to. Divide, okay? To find the common ratio. Any questions? Anyone still writing? Okay, Larry, let me know when you finish, babe. It says Terrence is spending its spending account balance is represented here. So look, if this is, I'm gonna put Y, okay, instead of A sub T. What is that 100 represent there? What is the 100? This is the starting amount. So this is how much he opened that account with, right? Okay. Now it's asking for what is the balance after 2 weeks. So what do we do to figure out what the balance is after 2 weeks? Convert the two, let's see, what is it? T represents the number of weeks. So all I'm doing is substituting 2. That's even easier. So we're going to replace T with 2. So that gives you 100 times point what? 9 caret key what? 2. And what is that amount? 81. Okay, this is 81. Raise your hand if you're still writing. A scientist conduct an experiment to observe half-life. Remember, half-life of something is how long it takes for them to be half of the original dosage. So if it starts at 200, its half-life is 100. So you have to figure out how long did it take for it to get to 100. How long did it take for it to get to 100? 13 days. This is right here is where the half-life is. Any questions about that? Okay, so now this is bacteria. Sorry. I'm sorry. That was not right. I'm sorry. Forgive me. Sorry. It's my initial reaction though. Okay, so now they want to know how many days it's gonna take for it to get to 1.5. So what is X when Y is 1.5? So we're gonna do exponential reg so that we can view the function table. So let's second plus 7, 1, 2. Go to stat, edit, and type in the numbers. All right. After you type in the numbers, what do you do? What do you do after you stat, calc, zero.
Second.
Oh, sorry. Then second, one, comma, second two, comma, bars, Y bars, enter, enter, enter. Good job, baby. All right, so now we're going to view the function table. The equation is here, so now you can view the function table. What two buttons you press to view the table? Second graph. So now you're going to look for what is x when your y is at 1.5. Or you can look, remember, don't forget, you can type in the x's. Press second window, go over to x, and now you can type in your x values. So we got 13. No, that's too high. 65. No. 91. Yes. And I 10. That's gonna be. So it's what? 91 days. Okay. What is the y-intercept of this function? Guys, don't be misled. Some of you are gonna put 1 because the number that's in front of is the y. No. The y-intercept is always going to be when x is equal to 0. Okay? So you're going to plug in 0 for x and solve. So your y is going to be 3 over 2, put it again, 0 minus 7. Okay, what's any number raised to the 0 power?
1.
It is 1. Good job. So now we have 1 minus 7. What's 1 minus 7? Negative 6. So your y-intercept is negative 6. It crosses at 0 and negative 6. This is the y-intercept. Please write. Pause for the cause. I don't know. It's teacher work day? Oh, okay. Cell phone, pick those up. Please study. Your test is on Monday. Please study. Thank you so much. Monday. I didn't think we had school. Oh, hand me your packet on the way out the door. Listen to my good. Packet. Take out your notebook and your packet. Packet, I need. Give me your packet, please. Come on. Come on, let's go. Guys, have a seat. Ladies, have a seat. Don't forget to pick up your calculator. Go ahead and open up your notebook.
Bryson ain't.
Pack it. Pack it, take it out, put it on your desk so I can fill it out.
You do like one night of homework. I'm just gonna turn it in.
I didn't do any of it.
Take the tab. It's just like this is mine now. It's up to that one. Okay. Can I sit up there with you? No. No. I'm alone. Packet. Take out your notebook, please.
Yeah.
Take out your notebook, please. Packet.
Oh, packet, I forgot about that. I got it, Mr. It's right here. It was right here. I got it, right here.
Packet.
It's cold underneath my desk. It's cold underneath.
Make sure your first and last name is on your packet.
It's cold. I didn't say why. I said it is. Yes.
Hey, take out your notebook, please, so we can finish the study guide. Take out your packet, please, so we can finish the study guide. Come on, baby.
I don't got a pencil.
Okay, but that don't mean your notebook can't be open. Uh-huh.
I have some.
I was almost finished with the study guide in the last class, so I'm going to record this last problem. Okay, so I want you to write this one down, and then I'll go back and do the other problems. Okay, write down the work, not the problem, the work. You ready? So we're doing 25 first because I didn't get to do that, and so I want to do this for this video so I can post the video. Y'all ready? This goes in your notebook with the study guide. Okay. All right. All right. So it says Mrs. Turner's has two different accounts that can be modeled with the equations. This is the first equation. This is the second equation. What's the starting amount for the first account? What's the starting amount for the first account? Very good. This is the starting amount for the first account. What's the starting amount for the second?
3,500.
Okay, very good. Okay. Which one is which? What kind of function is the first one? This is growth. What's the second one? This decay. So one is increasing and one is decreasing. Okay. All right. So let's read the statements to see which one best describes the two accounts. It says account one is example of exponential growth. It is. Account two is example of exponential decay. That is very true. This is a good answer. Okay, but it says best. So we need to read all the answers to see which one describes it the best. Are y'all okay? Can you expedite this process, please? All right, here we go. So the second one, it's a good answer. We want to make sure it's the best answer, okay? Account one is exponential decay. It is not. No. Both accounts, account one and account two, examples of exponential. No, and both are no. So the best answer is A. Okay. All right.